All right, so what's the problem with this particular one? When we try to evaluate the limit, what happens? We get it to 0 in the denominator, and that's impossible. We cannot divide by 0. So what shall we try? Let's try and eliminate the bottom. So in order to eliminate the bottom, we have to be able to cancel something from the top as well, right? So let's try to factor. So the limit as x goes to 2 of something over x minus 2. If this is going to work, then we better be able to factor out an x minus 2. Does that make sense? So there's a hint. Okay, use that strategy to help yourself out. So x squared plus 2x minus 8 will factor into x minus 2 and... Okay, now that they're separated, they're factors, right? Now we can divorce them. We can't cancel unless they've been separated or factored, right? So sums and differences don't cancel, but factors do. X minus 2 over x minus 2 cancels. And we're told now that we need to evaluate the limit as x goes to 2 of x plus 4, which is 6. Because everywhere we see x, we plug in a 2, and 2 plus 4 is 6. Questions on that one? Makes sense, right? All right, so here comes our next one. By the way, this is what this looked like, because when we factored it, right, this was a polynomial, a trinomial divided by a binomial, and we factored it, we have a line that has a slope of 1 going through the point 0, 4, slope-intercept of 4. So we're rising 1, running 1, rising 1, running 1, so it was approaching the number 2 for x and the number 6 for y from both the left and the right-hand side. So even though that function does not exist at that point, the limit does. Okay, so here comes our next one. Question. So I just said, let's put this into the calculator and see what Desmos says, right? And it says, hey, I noticed that these two are going to cancel. So this is really the equation y equals x plus 4. So this is like a 1x plus 4, where 1 is our slope and 4 is our b, our y-intercept. And then we'd have a hole at that spot. Okay? All right, other questions on this one? So let's try this next one. Now we want to take the limit as x goes to 2 of the quantity x minus 2 over the quantity x cubed minus 2x squared plus 2x minus 4. I have a feeling when we plug 2 in there, what's going to happen? Probably going to have a 0 in the denominator, right? Is there a fast way to plug something like that in? Does anybody remember from last semester? Really quick way to plug it in, and if you have no remainder, if your remainder is 0, then you know it was a synthetic division. Shall we try it? Synthetic division, we would need to put what up here? A 2 on the outside, and then what do? We get 2, add, we get multiply, add, multiply, add. Okay, so we know that x minus 2 was a factor. That 2 is a 0, right? And so that helped. Okay, so yeah, if we would have plugged a 2 in there, we would get a 0 in the denominator, and we know we have a problem. So what are we going to do? We could group. Okay, so if we're going to group, that's going to mean the limit as x goes to 2 of x minus 2 over, what did these two guys have in common? What's left? What do these two have in common? What's left? So our factors will be and that's great. Now that we've separated them, they can be divorced, right? So we can cancel. When they were added or subtracted, we can't cancel vertically, but we can once they've been factored. Oh, guess what? Same thing, right? We found our other factor, x squared plus 2. Okay, so some of those tricks that we learned last semester can come back and help us this semester. Okay, so now let's evaluate that limit. The limit as x goes to 2 of 1 over x squared plus 2 is going to be what? 1/6. And graphically, that's what this function looks like. It's rational equation. And even though the function is not defined when x is 2, because we're approaching the same number from both sides and it happens to be 1/6, we have a limit that is defined at that point. Questions on that one? Okay, next one. Quick check, plugging 1 into the denominator, we get 0, so we can't evaluate the limit yet. So what are we going to do? Remember difference of cubes? So you're same, opposite, always positive. SOAP is the acronym for the signs. So it's going to have the same sign that it had before. But then this will be the opposite sign, and this will be an always positive. Okay. What goes in the next spot? What are we going to have to multiply a by to get a cubed? What do we have to multiply b by to get b cubed? What goes in there? Anybody remember for sure? AB, the product of the two. Okay, should we try synthetic division to see if we're right? Can't hurt anything, right? We had an x cubed minus x, so what does that look like synthetically? What goes out in front? So 1x squared plus 1x times plus 1 times that x minus 1. Now that they're factors, we can cancel. Can't cancel sums and differences, only factors. So what's the limit as x goes to 1 of 1 over x squared plus x plus 1? 1/3. Walk down memory lane, right? Remembering how to factor by grouping when we have 4 terms. Remember how to factor difference of cubes. Yes, it's a straw, not a walk. A sachet. Okay, this is what this graph looks like. We graphed it. And at 1, we're undefined, but notice that we're about 1/3 of the way up. Okay. From the left and from the right, we're approaching that same value. So even though the function's not defined there, the limit is. So far, so good? Questions on this one? Okay, next one. So everything was pretty good until now. We look at this and we say, oh no, what's going on? We have a 0 in the denominator. So thoughts are, it would be nice if we could square something, right, to get rid of radicals, because we see that radical and we think maybe that could help with stuff, okay? The problem is, though, do we have an equation or do we have an expression? Expression. So if we're going to try to square something, we have to square both sides of an equation to make that happen, right? So that doesn't quite help, but I like where you're going with trying to eliminate that square root. So what else could we do to eliminate the square root? No, he has the thought. So it's currently to the half power, right? So could we do something with the half power to try? Or could we get something on, could we do something to the top and then have something happen to the bottom, the same thing happen to the bottom, right? If we multiply, okay, but we can't square the top because when we try to square something, if it's like the square root of x equals 3, we have to square both sides of the equation, right? But we don't have an equation. There's no equal sign. No, there's no equal sign. There's a minus. There's no over to put it to. So it's not an equation, it's an expression. But what if we multiply by the square root of x plus 9? Say it louder. Plus what? Or with what? Both top and the bottom. That's almost going to help us, right? But let's do like the conjugate. That's the word that Pablo was trying to say, right? Pablo? The conjugate? Okay? Because then we're multiplying by 1, and that's legitimate. We can multiply the numerator and denominator by the same thing, right? We're truly only multiplying by 1, but we're just changing the appearance or what's happening with it. Okay, so let's see what happens. So first times first. Outsides, 3 times the x squared of x plus 9. Insides, negative 3 times the square root of x plus 9. They're gone. And then negative 3 times negative 3, or positive 3 is? All right, did that help us? Okay. I like that. The limit as x goes to 0 of x, because these are gone, over x times the square root of x plus 9. The x's are now factors, so we can cancel them. They're separated. No divorces without separation, right? And now what is going to happen when we evaluate the limit? sense? A lot of work. And not intuitive necessarily, right? Okay. But it works. Okay. Questions on this one? Yes. Okay. So we said just like if we were working with complex numbers or what have you, and we wanted to eliminate, remember when we did things like 5 plus 7i over 2 minus 3i? And we had to multiply by 2 plus 3i over 2 plus 3i? Because that makes the outside insides disappear. Okay? So it's the exact opposite of whatever we're trying to eliminate. Okay? Or same thing with 5 minus the square root of 2 over 3 plus the square root of 5. We're going to have to multiply top and bottom by 3 minus the square root of 5. Same idea. Okay? All right, so what would this graph look like? Kind of boring. Okay? Flatlined at 1/6, right? Okay? Only undefined there when x is 0. All right, questions on this one? We're good? All right, how about this one? Now, when they say approximate the limit, I'm not sure why I had this one as a particular example, because we could evaluate this one algebraically, right? Okay, when we evaluate this algebraically, we notice that when we plug a -1 in, we're going to get a 0 in the denominator. So we're going to try to factor. Does it factor? So x plus 1 times what? It's factors of 5 that subtract to become a -4 are a -5 and a +1. Cancel. They've been divorced. -6. Okay? But what they're asking you to do when they ask you to approximate, they're going to tell you at some point use a graphing calculator to approximate, and this is what they're wanting you to do. Right? And we know how to set up the table, right? We know how to graph something and zoom in closely and see what's happening on both sides, right? So we won't take the time. We did that a couple days ago. Okay? All right, last example. All right, so listening to your conversations, you're saying, hey, let's just try to evaluate this limit. And if we took the tangent, I guess I don't need that. I'm going to put the zeros in. We're going to basically have the tangent of 0, which is going to be 0. But then 0 over 0 is undefined. It does sound a lot like 1, right? So then we could try some different things, right? Second hour, someone said, well, what if, if we do something to the bottom and the top, as long as we do the same thing, could we take the inverse tangent of the numerator over the inverse tangent of the denominator to eliminate things? So if we tried that, This just gets this x on top now. We've moved it, right? And what's the inverse tangent of 0 when we try that? We're still back to 0 over 0, right? So this is where, even with your best efforts, we try to factor, we try to eliminate by factoring and then canceling. We can't do it, can we? So this is when we have to go back to our tables or to the graph. Okay? And what's happening here? Well, looks like we have some sort of asymptote, right? Okay? And another asymptote over here, right? But what's happening as we get closer and closer and closer to x being 0? 1. And 0 over 0 looks suspiciously like 1, right? So even though the function's not defined here, the limit is still going to be 1. So it's going to be 1. Okay, which is why the graphing calculator still could come to the rescue at times. Despite our best efforts, we may not be able to do anything that can eliminate things. So the bottom would have said the limit as x goes to 0 of x over the inverse tangent of x. When we plug in zeros for both places, the angle who has a tangent of 0 is going to be 0 degrees or pi, but the inverse tangent is only defined in quadrants 1 and 4. So 0 is its answer. So we end up with a 0 on top and a 0 on the bottom, which still didn't help us algebraically. So we have to go graphic. Okay, questions on these? All right, here we go.